In this video, I'm going to tell you that light is actually not moving as fast as you think. Sure, when you flick the switch of a light, immediately the entire room is filled with light. Or if you turn on a torch, then immediately you can see the object you're shining at. But that's just because that we are on such a small scale. In the average room, light can cross the average room in just 1/500th of a second, which is basically instant to our eyes. But that's because we are on such a small scale. So light can circle the entire Earth 7 times in one single second, which is why instant communication is possible. However, as we travel further and further and further away from Earth, light becomes slower and slower and slower until the point at which light starts to resemble more like a snail rather than light speed. To just see what I mean, let us consider the time light takes to cover from Earth to the moon. This time is 1.225 seconds, which is obviously far from being instant. Which this means that if you were on planet Earth and you sent a message to a moon colony on the moon, then the moon colony will only see the message that you typed 1.225 seconds after you have posted it. And once they have responded, it will take another 1.225 seconds for you to see it again, which means that the total response time would be about 2.6 seconds. However, communication on the moon is very easy compared to some other planets. Let's move now to Mars. Mars is a full fifth. Now, Mars is a different orbit from us. So, the distance from Mars to Earth varies rapidly. I mean, not rapidly, but greatly. At its closest, when Mars is closest to Earth, then the distance between then light will just take 3 minutes to travel from Earth to Mars, and even that is some time. However, it isn't when you consider the biggest distance between Mars and Earth, and that's a whopping 22 light minutes, which means that even if the colonies on Mars were able to respond to any message they get from Earth immediately, and you sent a message to them and they responded back when you see your message when you and Mars were at the farthest end from each other, then the response time would be 45 seconds. However, when we get farther out into the solar system, things become vastly longer. Jupiter, the time that light takes to travel from Earth to Jupiter, for example, varies from anywhere from 33 minutes to almost an hour at 53 minutes, which means that just to send instructions and signals and to get a response, people who are conducting a mission to Jupiter sometimes have to wait for 2 hours just so that they can send a message and then get a response, unless the probe sends a response before the message even reaches the probe. But that is impossible. Which means that sometimes the messages don't arrive in time for the probe to be saved, and that could lead to losses of the probe. And don't even try to communicate with someone on Pluto or somewhere farther, because light from Earth to Pluto can take up to 5 hours just to reach Pluto, which means that in the future, when there are colonies on Pluto and you send a message from Earth to one of those colonies on Pluto, there would be a response time of 10 hours, which is half a day. Now light is starting to become a snail. But we can go even further. The nearest star to Earth, for example, is a whopping 4.22 light years away from us, or 24 trillion miles. Its name, Proxima Centauri, is Proxima Centauri. If there are colonies on its planet Proxima Centauri B, and you were on Earth and sent a message to one of those colonies, then the colony would only receive the message after over 4 years, which means that the response time is almost a decade. And that's just in our local cluster of stars. If you try to communicate with something at the other end of the Milky Way, then the response time is 200 light years. So, yeah. The reason why light is so fast is because we are on a small scale. But when we zoom out to a humongous scale, light is a snail. Done.